this question is from geometry. In this question, we are given a figure which is a combination of a square and a rhombus. Area of square is 25 and the area of rhombus is 20. And we need to find the shaded area, this pink color area. Let's see how we can find this area. We will be solving this question in three parts. We will be solving this question in three parts. Let's look at the first part. According to first part of the solution, we will be using the given information to mark certain sides of this figure. According to this, the square ABCD has area equals to 25, correct? That means side times side will give us 25. That is the area of square. So side will turn out to be 5. So let's mark the square ABCD with side equals to 5. According to this, AD will be equals to 5, CD will be equals to 5, and AB will also be equals to 5. Now, we are also given that rhombus PQCD has area equals to 20. Now, what is the area of rhombus? It is base times height. Yes, this is equals to 20. As we can clearly see in the figure, the base of rhombus PQCD is 5 times height is equals to 20. That means height is equals to 4. Height of rhombus is 4. So let's draw the height of this rhombus in the next part of the solution. In the second part, as I told you, we will be drawing height of rhombus PQCD and we will see how we can use it. So I'm drawing this height from point P and I will also join BC. BC is nothing but side of a square. I'll draw a dotted line because it is behind the rhombus. Yes, because it is behind the rhombus. That's why I will be drawing it as a dotted line. Correct? Now, after this construction, let's see what we can do. This is height. So this is perpendicular 90 degree. As we told you, this is 4 and PD is the side of rhombus and side of rhombus are all equal. CD is also side of rhombus. So PD will turn out to be 5. I'll just quickly write here that in rhombus PQCD, CD is equals to PD, which is equals to 5. Yes, please keep this in mind because these are sides of a rhombus. Now we will be applying Pythagoras theorem in this right triangle. I will mark a point here so that you can understand properly. Let this be point X. So we will be applying Pythagoras in right triangle PXD. We will be applying Pythagoras here. Now, according to Pythagoras, we know that px square plus xd square is equals to pd square. So what is px? It is 4 square plus xd square is equals to 5 square. We very well know that 3, 4, 5 are the Pythagorean triplet. So xd will turn out to be 3. xd will turn out to be 3. Let's mark this in the figure. xd is 3. See, if cd is 5 and xd is 3, xc will turn out to be 2. xc will turn out to be 2. And if xc is 2, definitely this part, let me name it as py. If xc is 2, py will also be 2. py is equals to xc. Both are opposite sides of a rectangle pycx. Correct? Now, let's move to the third part or the final part of this solution. So in third part or the final part of this solution, we will be finding the shaded area. Let's see how. Shaded area can be found out by finding the area of square ABCD and subtracting the area of trapezium or trapezoid PYCD. PYCD. Correct? This is how we can find the shaded area. Now, what is the area of square ABCD? We very well know that it is 25. It is given in the question itself. Now, what is area of trapezium PYCD? That area of any trapezium is half times sum of parallel sides times height of that trapezium. Correct? So minus half times sum of parallel sides. What are the parallel sides in this trapezium PYCD? It is PY and CD. These are the parallel sides. That means 2 plus 5 times height. What is the height? Height that we have found out, px. Yes, 4 is the height. So times 4. So if we solve this, we will get 25 minus 14. Yes. So what will be our final answer? Area of shaded region? Let's see. Our final answer will be 11. 11 will be the shaded region. This will be our final answer.